images are basically just a collection of numbers. One image is really just a point. And that's the heart and root of machine learning. You interpret the data as some sort of points. And you want to figure out automatically how to find these boundaries between different objects. Often you do this by collecting lots and lots of data. So this is an example of the bicycle helmet holding. So you collect, in this case, you have sensor data, accelerometer, and gyro. So you can collect lots and lots of data of sensor data that happens just before an accident. So that's where you want it to inflate. And then you have lots of examples of sensor data where there is not an accident. And that's where you don't want to inflate. So the sensor data for one category becomes the blue dots, and another category becomes the red dots. And you want to figure out, can I find an automatic way to figure out from the sensor data, should I inflate or not? The revolution within machine learning, it really started out with trying to do really difficult problems, such as categorizing images in 1,000 categories. So this is one of these 1,000 categories, the category hammer, and then you collect thousands of images of hammers. And then you collect thousands of images of ladles, slevar, and then toilet paper, and grapes, and dogs, and Dalmatians, and 1,000 different words. And then you try to solve them. And first you solve them with other techniques, and the error rate was like 28%, 26%. And then we tried these deep learning techniques where you have these architectures with millions and millions of parameters. And then we started getting performance that really dramatically dropped, and now they're like down to 3% errors. And human performance is 5%. We applied this to medical images, to understanding how cows move in a dairy farm, understanding where the free parking lots are, how pedestrians move and bicycles move in traffic. So there are lots and lots of applications of this. We know that there are connections, architectures in the brain, neurons. We know a little bit about what's happening in different parts of the brain. And you can actually, in animals, you can go in and measure what's going on at different points. And it turns out that if you measure at a certain point in the brain, you can figure out that this part triggers when you see bars in certain orientations and certain sizes. There are some very interesting features that we have in the human brain that we don't have a clue about how to calculate. But there are specific features that trigger if you're close to a wall or close to a cliff. There are neurons that trigger if I'm in a specific spot in a room. So I have one neuron that will light up if I'm here, but then it will be quiet when I'm here. So we know bits and pieces of what's going on in the brain, but we don't know really how these are connected and how they're computed. But again, there are some connections to what's going on in deep learning.
Our visual attention corresponds to a high degree to what we are thinking about. We actually need to move our eyes constantly. That is just an illusion that we think everything is in focus all the time. It's just a very small part of our visual field where we can look in complete focus. And the fixation is when our eyes are still and focused on something, and in between those fixations we have saccades. So those are really, really quick movements in between those focus points. And during those saccades we're actually blind, so we cannot take in any information. Our attention is also limited and highly selective. It can be really hard to detect changes if we're not closely paying attention to them. It also makes us very, very vulnerable. So maybe those self-driving cars isn't such a bad idea after all. So eye tracking gives an insight to a person's subjective experience. And the eyes do not work like a camera. We need to move them around all the time because we have really this very small part of the visual field in focus. And eye movements are task dependent, depends on what you want to do in the environment. And our visual attention, as you can see, is very limited and highly selective.